Hello and welcome to everyone. First of all, thanks for taking the course. I am Shuman Ahmed with you. What you will learn in this lecture: the Arduino IDE interface layout, configuring the Arduino IDE to work with your Arduino, using the serial monitor feature in the Arduino IDE. Overview of the IDE. The menu bar provides access to all the features of the Arduino IDE. From here, you can create a new program, open an existing program, automatically format your code, compile your program, and upload your program to the Arduino unit. The following sections discuss each of the options you will find in the menu bar. Also available the file menu, which contains all the file handling options required to load and save sketches, along with a couple of the miscellaneous options. Another important menu is the Help menu, which provides links to help topics for the Arduino IDE. If you don't want to have to navigate way around the menu bar to perform functions in the Arduino, you can use a handy toolbar just under the menu bar. The toolbar provides icons for some of the more popular menu bar function. In here available, Verify to performs the verify or compile option. Upload, provide the compiled sketch code to the Arduino unit. New button, which provide create a new sketch tab in the Arduino IDE window. Displays the file open dialog box that allows you to select an existing sketch to load into the editor. Save, the down arrow icon. The provide saves the sketch code into the current sketch file name. Serial monitor, the magnifying glass icon, opens the serial monitor window to interact with the serial port on the Arduino unit. The message area and console window of the Arduino IDE. The console window often displays informational messages from the last command you entered. For example, after a successful compile, you'll see a message showing how large the program is. If there are any errors in the compiled sketch code, both the message area and the console window will display messages pointing to the line or lines that contain the errors. Set up the Arduino IDE. You should be able to work with your Arduino IDE with most of the default settings. However, you will need to check on two main things before you start working with your Arduino unit. First thing, you have to connect your Arduino Uno board with your computer. Then select the board model that you are using to ensure the compiler generates the proper machine code for your Arduino unit. For this, click on Tools menu bar, keep mouse on board level. You should see list of Arduino families. Then click on Arduino or Arduino Uno. The second thing to check is the serial port. Click on Tools menu bar, keep mouse on port level. You should see your board name and communication number. Then click on the year board number. Once you have your Arduino IDE set up, you're ready to start working on projects. Now explains the basics that you need to know to start writing your sketches and getting that to run on your Arduino. The Arduino program specifically looks for two separate functions in the sketch. One is void setup and another is void loop. The Arduino calls the setup function when the Arduino unit power up. The code you place in the setup function, it only runs for one time. Then the program moves on to the loop function. An example, program a blinking LED. Let's explains how program works. Declare an integer type variable instead of using 13 number pin in the program. Then initialize the variable as output by the pin mode function. Digital write is output built-in function of Arduino IDE. For the delay time, use built-in function delay and assign 500 milliseconds. Then I repeats the code for turn off LED. Let's check on Proteus Simulator. The LED turn on and turn off according the program code. But it is not repeating because setup loop work only one time after power on the Arduino board. Now look the void loop function. Here, just copy the program code and paste into the void loop function. Now again, let's see on Proteus Simulator. Now it is repeating the LED because the void loop function will repeating until you disconnect the power from Arduino unit. Let's take a tour of basic of programming C language. which is the foundation of the Arduino programming language. It first explores how to store data in your sketches using variables. Then it discusses how to perform simple arithmetic operations in your sketches, instead of having to reference specific memory locations to store your program data. The Arduino programming language uses simple variables to represent memory locations for storing data. The Arduino programming language is built on the C programming language. It uses the standard C language format for creating and using variables. In the C programming language, creating a variable requires two steps. One is declare the variable. Another one is assign a data value to the variable. While declare a variable, you just define the type of data that the variable will store and the variable name in a statement. You have to follow a few rules when declaring C variable names. The variable name must contain only letters, numbers, underscores, or the $sign. The variable name must start with a letter. The variable name is case sensitive. There is no limit to the variable name length, but it should use under 32 characters. An example, for declare a variable, you have to declare data type before create a variable. Use underscroll between two or more words. Capital letters use first every words. Also, you can declare number with variable, but number have to write after any letter. After declare the variable, you need to assign the value, which you will use in your program. In this case, you can assign by two methods. One, you can take a shortcut by declaring the variable and assigning the value in one statement. Or you can assigning the value after declare the variable in next line or in the program console. You will learn in the next lecture. Understanding data types, variable qualifiers, variable scope, standard math operators, using compound operators, and more. Thanks for watching this lecture.